This is about the survival of the human race, a sign of the times, an analysis, and a commentary. Mars Curiosity Rover finds signs of ancient habitable environment. Powder drilled out of a rock on Mars contains the best evidence yet that the red planet could, would, should have supported life billions of years ago. The team behind NASA's Curiosity Rover has said the findings are in line with what the scientists hoped to find when they sent the 1-ton, 6-wheeled laboratory to Mars' Gale crater. It wasn't serendipity that got us here. It was the result of planning. Caltech's John Grotzinger, the mission's project scientist, told reporters at NASA headquarters. Serendipity did, however, play a part in being able to find the evidence so soon. It's much more than all that. Curiosity's handlers had planned ahead for the mountain in the middle of the crater, but once the rover landed, the science team decided to take a detour to a geologically interesting area in the opposite direction. And so they say, several billion years ago, Mars may well have been a pleasant place for tiny microbes to live, with plenty of water as well as minerals that could have served as food. But they have yet to find signs that actual microbes did live in that oasis. We have found a habitable environment that is so benign and supportive of life that probably, if this water was around and you had been on the planet, you would have been able to drink it, said Grotzinger. And drilling into its first rock, a fine-grained mudstone, the scientist said, the rover Curiosity sent back to Earth convincing evidence that Mars was once awash in water. Plus, the Curiosity scientists identified elements in the rocks: sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon, that are some of the key ingredients of life, as well as minerals like sulfates and sulfides that primitive microbes could eat for food. He also added that these minerals are effectively like batteries and could provide an energy source for life. This included the presence of clays, one of the main things that scientists were hoping that Curiosity would find on its 2-year, $2.5 billion mission. Clays form in waters that have a neutral pH. What we have learned in the last 20 years of modern microbiology is that very primitive organisms, they can derive energy just by feeding on rocks, he said. Even so, the Curiosity scientists said they had not yet definitively found the carbon building blocks needed to come together to give rise to living organisms. 2 earlier NASA rovers, Spirit and Opportunity, also found strong evidence of liquid water on the Martian surface, but in places on the planet that were highly acidic and salty, far harsher for any hypothetical organisms. Curiosity landed in August in a 96-mile crater named Gale, gouged long ago by a meteor. These scientists and engineers have been taking a deliberate, careful approach to checking the rover's systems. The surface of Mars today is cold, dry, and battered by radiation from space, but planetary scientists think young Mars, more than 3 billion years ago, was a far more hospitable place with a thicker atmosphere, warmer weather, and water flowing at the surface. Some scientists believe that if life ever took hold there, it might persist even today beneath the surface. Curiosity is not carrying any instruments that can detect Martian life, past or present, but it can identify so-called organic molecules which contain carbon and hydrogen atoms. the presence of organic molecules would not prove the presence of life, since many non-living chemical reactions can produce organic molecules. But organic molecules are necessary for life, at least life as we know it. So far, the Curiosity scientists cannot say that the rock contained organics, but neither can they rule out the possibility. Rather, since their instruments did measure some simple organics, the researchers are sorting out whether the organics came from the Martian rock, from contamination brought from Earth, or were formed in chemical reactions as the rock powder was heated. Still, the scientists are excited by the possibilities, but the answers will take a while to discern. In other words, Mars' past, present, and future are all connected in some kind of way, and Mars is a part of the future of mankind. This too is another sign of the end of times as we know them, transition days, which is a time of extraordinary happenings, changes, and events, because, again, it's about what kind of world or worlds are we leaving to the future generations, and that should be a very important question to ask. Genesis chapter 1. In the beginning, God created the heaven and the earth. 2. And the earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. 3. And God said, Let there be light, and there was light. 4. And God saw the light, that it was good, and God divided the light from the darkness. 5. And God called the light day, and the darkness he called night, and the evening and the morning were the first day. 6. And God said, Let there be a firmament in the midst of the waters, and let it divide the waters from the waters. 7. And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. And it was so. 8. And God called the firmament heaven, and the evening and the morning were the second day. 9. And God said, Let the waters under the heaven be gathered together unto one place, and let the dry land appear. And it was so. 10. And God called the dry land earth, and the gathering together of the waters called he seas. And God saw that it was good. And all these are more signs of the times. Everything is connected, and everything is numbered. This is the way it is. Everything that must change quickly or rapidly, and for the better. It's time for prophecy to be fulfilled.
Hi, I'm Joel Hurwitz, a scientist with Curiosity's Surface Sampling System team, and this is your Curiosity Rover Report. This week, the Curiosity Science team released its initial findings from its first ever drilled sample on Mars. This sample was collected from the John Klein drill site, which is located about 500 meters east of where we landed about 7 months ago. Curiosity obtained her first drill sample and passed that sample on to her onboard analytical instruments called ChemIn and SAM. These powerful instruments tell us about what minerals are present in these rocks and whether they contain the ingredients necessary to sustain life as we know it. What the Curiosity team has found is incredibly exciting. When we combine what we've learned from our remote sensing and contact science instruments with the data that's coming in from ChemIn and SAM, we get a picture of an ancient watery environment which would have been habitable had life been present in it. As an example, the information that we're getting from the ChemIn instrument tells us that the minerals that are present in this lakebed sedimentary rock at John Klein are very different from just about anything we've ever analyzed before on Mars, and they tell us that the John Klein rock was deposited in a freshwater environment. This is an important contrast with other sedimentary environments that we've visited on Mars, like the Meridiani Planum landing site, where the Mars Exploration Rover Opportunity has been operating since 2004. At that site, sedimentary rocks record evidence of an environment that was only wet on a very intermittent basis. And when it was, the waters that were there were highly acidic, very salty, and not favorable for the survival of organic compounds. This is in direct contrast to the freshwater environment we're seeing here at the John Klein site. The SAM instrument is telling us that these rocks contained all the ingredients necessary for a habitable environment. We found carbon, sulfur, and oxygen, all present in a variety of states that life could have taken advantage of. All in all, these few tablespoons of powder from a Martian rock have provided the Curiosity science team with an exciting new data set that tells us that Gale Crater, and perhaps all of Mars, contained habitable environments. This is an incredible success for the Curiosity mission to Gale, and the science team is looking forward to digging deeper into Mars's ancient watery past in the weeks, months, and years ahead. This has been your Curiosity Rover Report. Check back for more updates.